Hello and welcome to today's webinar. My name is Sarah Summers, and today we will be talking about common cut nesting. Our webinar today will be hosted by Lloyd, and he is one of our senior application engineers. But before we get started, I want to go ahead and go over the controls with you. The questions panel is either at the bottom or right-hand side of your screen, depending on your setup, and you can feel free to type in questions at any time. We have one of our engineers here, Jim Chisholm, to answer questions as they come in, or they may be addressed by Lloyd at the end. This webinar will be recorded, so if you would like to share it with someone at your company or have it for yourself to review later, you can feel free to do so, and you'll be receiving a copy of the recording within the next couple of days. So I'd like to take this time to introduce Lloyd and to introduce the topic common cut nesting. So I'm going to go ahead and give him control, and we'll start our webinar.
Hello, everybody. This is Lloyd. I'm with Sigmatek, and today's topic is the common line nesting and some of the nesting features, along with some of the NC features that we'll be going over. So let's go jump right into it. First off is my name is Lloyd Leichentritt. I am a senior applications engineer with Sigmatek. I've been here for 8 years. I've been in the industry for about 27 years. Worked for several OEMs like FinPower and Bystronics. All right, so today what we're going to be doing is going over the part parameters setup for how to set up the common cutting at the part level. There is a new location for the 1.5, so it has been moved from our previous versions, and we'll show you where that is. And then we'll also be discussing the task parameter setups for the common cutting types for single part, same part, and multiple part nesting, along with how to control the kerf for the kerf controls. And then we'll be going into some examples for the nesting, along with the NC commands for the auto NC, for things like the common cutting type or the sequencing, the options that you have. We have what we call pickup options that are for the avoidance of part tip-ups, if you will, and also how to control the lead in and lead out settings. Okay, first off is when you need to do common cutting, you have to have either Techno or the PowerPack software package. That the two modules that enhance this is the advanced automatic nesting and also the advanced NC profiling. Those two will do the automatic nesting for the common cutting, and then the profiling, the NC side of it, for the profiling and the cutting. If you have TrueShape, they do not include those two modules, but they can be purchased. You can get away with just the advanced profiling module just to do the NC side of it, but you will have to do the manual nesting of the parts themselves. If you do want to purchase both of them, you can, but I believe it is cost prohibitive to go to the Techno before you do the actual purchase of the two modules. Okay. All right, so now let's start with the part parameters. Within the part parameters for X1.5, we have moved the checkbox for the common cutting to select the part for common cutting to the actual part data tab. It used to be in the grain tab. We have now moved it to all the checkboxes within the first tab when you first open it up, so you don't have to go through and cycle through all the tabs to double check it. Okay. Once a part has been checked for common cutting, that gives the ability for that part to be nested at the nest level for common line cutting. If you have the common line cutting turned off at the nest level and the checkbox is still turned on, it will nest it normally. So both have to be satisfied, where the part has to have common line cutting turned on along with the task parameters, and then a part can get common cut based on the settings at the part level. Okay. So the common cutting will then allow you to configure the common cutting part to be shared through common cutting lines, or a shared line. All right. So the ability to select which or how, what type that is all done at the nest level within the task. All we're doing here is just giving the capability of the common cutting to be turned on at this stage. Okay. The next one is the task parameters. So once a part has been selected for common cutting, and then you create your task within the task parameters, we have the common cutting section on the left side down below, and you can see that in the red highlighted area. Okay. We start off with the common cutting types, which is going to be the off for no common line parts will be nested through the common line feature, and they would be nested normally. The other three functions are single part, same part, and multiple part. Single part will find one common edge off of that part and then nest it to the same part, giving you a grouping of two parts of each of those parts. Same part will find any common edge that's available on the part itself, and you'll get more of a grid pattern. So if you had a square, all four edges then would be a common edge. Therefore, you'd get a grid pattern of those parts. If you selected multiple parts, that means then parts that have the common line cutting function turned on can be matched up together within the task. Versus the same part, you'll get a grouping of that part by itself, and then you'll get maybe another grouping of that common line cut part by itself, where the multiple part will then match smaller and larger parts together and try to cut them within the same geometry. So the first example is going to be the single part nesting, and within the display here, what we have is a single part that's using a common edge off of one edge and mirrors it up or buddies it up to that same edge within the same part. The other side of the parts are using the normal part spacing that is put into the part clearance distance. The next option we have would be the same part. Now it's looking at all of the edges, and it will give you more of a grid pattern between the whole nest within that part. The multiple part option then will take small parts and large parts for all the parts that are selected as common line cut and try to attach them so that they're all using the shared edge, regardless if it's of the same length or not. So you can have a real long part with a smaller part still tagged onto it. Your other options for nesting and the ways that we were doing it before with those options would be the automatic nesting. You do have manual nesting where you can manually nest your parts, and you can use either the move feature using the align function to properly space your parts together, as long as the part spacing meets the kerf setting that is set up within the task parameters for the common cut. It will then configure that for common cutting. You can also use either the dynamic array or the array function to array your parts manually, to space out your parts, and then still have it common cut with the auto NC, providing again that the kerf value is the same, or the spacing is the same as the kerf value that you set for the common cutting. There's also the manual common cutting option within the Advanced NC tab that you can use, and all that does is it'll take a part and start nesting it based off of the common cutting kerf setting that is already preset. So now you have the ability to do it automatically and also manually. Next is once it's nested, then within the Auto NC, we do have the tab for the common cutting. Once the common cutting tab is turned on with the checkbox, then you have to select the actual common cutting type. There's 4 types. You have cut, rapid cut, 1 pierce 2 parts, 1 pierce 2 parts laser, and then auto slit. Okay. The next options that you have in there are the options page, and that's basically to control and set the kerf settings to how you want to control that. You have your third section, which is the previous pickup points, and that would be used for avoiding tip-ups by extending a cut into a part next to it, so that when the first part is cut, and if it does tip up, it does not hit the nozzle. And that's what the pickup points are used for. Lead in and lead outs. So when you want to use your lead in and lead out controls, that's all you need to do is select your length of your lead in and lead outs. The first section then, or the first option for the type, is the cut, rapid cut. Okay. If we follow the numbers through the display, you'll see that it goes through 1, side 2, side 3, side 4, cuts the whole part by itself, then picks up on sides 5, 6, and then 7. So it cuts out one part completely and then goes back to that common edge to pick up the other 3 sides of the other part. Okay. This is used mainly for either same part or for multiple part. Then we have 1 pierce 2 parts. What this does is it will go around the part through side 1, 2, and 3, split the center through 4, 5, 6, and 7 for the other part. Now, when it does that, when it goes through 5, 6, and 7, it's actually changing cutter comp. So it goes from cutter comp right, and then when it goes and splits the parts between the part itself, it turns off the cutter comp. And then when it goes to do the other part for 5, 6, and 7, it will then change the cutter comp again because it's going the other direction. Some machines do have a issue where you cannot change the cutter comp while you're cutting. Therefore, we have the function called 1 pierce 2 parts laser. What that does is it switches up the sequencing of how it cuts, but it maintains the cutter comp through the part itself. In this order, what it does here, it cuts the center through line 1 first, then goes around and cuts the outside of the part. And what this does is it maintains the original cutter comp so that it's not switching back and forth. Most laser systems will benefit from this. And again, this would be used for either a single part nest where it's just one part with one common edge. The next option that's there, type, is going to be the auto slit. What this does is it does all of the internal cuts first and then cuts around the outside. This can be used for single part, same part, and multiple part nesting types. Okay. This is the most fastest way to cut common line cutting, but it's the least inaccurate because as you're slicing up the internals, you are lowering the integrity of the parts themselves, so parts can shift, so that when you're also cutting the internals, that if the metal is shifting, that you can get some tolerances that might not be met if you're dealing with higher tolerances. Okay. But it is the fastest way to cut a grid pattern of parts like that. All right. Now, within the next section of the options, it's just how we control the kerf. Most people will set the kerf setting within the task parameters. So the use task parameter settings is the most commonly one that's used. As you're setting the common cutting setting, you're just looking at the setting in the dialog box and just setting it right there. Most people will use also within the kerf setting the kerf lookup. All that does is it goes into the tech table and pulls in the kerf setting that is from the set tech table for that machine, material type, and thickness. So the most important thing there is when we are pulling up a kerf setting from the tech table, that it is set properly from the actual tech table. If the tech table is not defined properly or has it not been set at that time, you can go ahead and offset that by using the user defined kerf settings and just manually type in what you need it to be. You also have the start position. You have shortest, you have the machine origin, lead-in, and stability cutting. This is just basically where you are starting the cutting on the part. The default will be shortest. That's the Sigmatek default, but you can set it to any one of the defaults, and then when you select your set to default, it will then maintain that positioning for you. There's a new function in here for the transition diameter, and there's a little diagram that we have. On the left side is the normal way of cutting a part through a common line cut with a radius at the corners, where it will basically go around the radius and then hop across the junction between the two parts and then continue on with the other radius. In some cases, that distance is very small and can cause some kerf settings to be rejected on the controller. So what they've done is they've added in a function here to transition that from a straight cut over to a radius cut. So instead of it looking now at a smaller contour like that, it puts in a radius to avoid some of the errors that a controller may have. The pickup points is the next option. Mainly, the pickup points should be used for rapid cut. It's typically not used that often for a single part or same part. Okay. So when you are using the rapid cut function, what this is going to do is extend the cut length by the length that you put in there. So typically if you put, let's say, 1 inch in the length, it will cut 1 inch into the next part. It'll start cutting one part, but when it gets to the common edge, it extends that into the next part itself by that distance, so that when you are done cutting that part, and if it is loose at that time and does tip up, that you are now 1 inch away from that part, preventing the a nozzle tip touch, if that actually happens. Okay. So you have the the options of none, which basically doesn't do anything, or you have standard prep cut or double prep cut. The ones that are used the most often is the double prep cut. What that does is it will then take that length and put it on all the edges of the lead in and lead out from the next part, or any part that it's touched to a common edge. So the double prep cut is the safest way. If you just go with a prep cut, it only puts in the safety cut for the lead in side of it, but then when it comes back to the common edge of the last cut, it still goes to the actual edge. So therefore, the double prep cut is the most versatile option to use, or most safest option to use for rapid cuts. The next one is the lead-in positions. So what this will do is, or not the lead-in positions, but the actual lead-in, lead-out settings. So you still have the option of doing line, reverse line, and then setting the actual line length itself when it needs to put in an actual lead-in. Regardless of the lead-in that's on the part itself, based off of the NC, will automatically determine where the lead-ins will go. Okay, so you do not have to worry about or readjust the actual lead-ins within the actual part itself. The automatic NC common cutting settings will compensate for that and take care of that automatically for you, especially for the nesting of the part itself. All right, so that is basically the common cutting presentation. And then what I wanted to do was actually go through a demonstration of the actual common cutting with inside of now Sigmanest. So I'm going to go ahead and open up my Sigmanest and basically run through some of these settings for you and what the flow would be. I'm just going to use a standard part. I'm going to bring it in to Sigmanest. It's going to open it up into my part parameters. And now within the part data, I now have my common cutting part checkbox, and I now have it checked. So that just gives me the ability to have the part common cut at the nest level. I'm just double checking my lead-in, so I have a lead-in for both my internals and externals. All right, everything looks good. I have this set to a Trump 5030, 5,000, or I'm sorry, an 8,000 fiber. Material is stainless steel, basically 1/8 inch. There's my part. I'm now going to create a task, pull the part over into my task, and I'm going to say I want, let's say, 40 parts. And then I'm just going to open up my task parameters. And this is where I get to set up your nesting type. So based off of your nesting types that you have, you could have a different result with the actual rotation of the part, depending on how you have that set. And also, you would have to respect any rotation within the part normally at the within the grain tab of any part, as you would normally do. So now I just have it on true shape, the HD true shape, and then I'm going to turn on now my common cutting setting from off. I will then use the single part, and then I'll activate my kerf lookup. And now what this is going to do is pull in the kerf setting, and it looks like it's set now to 16 thou from the actual tech table. So it's going into the tech table and then populating that value. If that is not the correct value, you either can adjust that and then redo the nesting, or you can turn it off and then just type in what it should be. So right now I'll just use the defaulted curve setting from the tech table. I'll go ahead and I'll hit OK out of the task parameters, OK out of the task setup, gives me my sheet. I'll just go ahead and auto nest. And now what I'm doing here is getting a grouping of two parts that are connected through one common edge. So this is the same function, or I'm sorry, single function, where it just uses the one edge as a common edge. And then if I look at the actual distance in here, I will then see the parts are separated by that value that I had in my curve setting, which was 16 thousandths. So if I measure the distance between the two, I have now a distance of 16 thousandths. The next thing I'm going to do is change the nesting type from my parameters from single part to same part. Now what this will do is look at all of the common edges that are available within the part and gives it the ability to use the all edges that are possible within there. In this case, all 4 edges in this case. So when I re-nest it, now it's using all 4 edges, and I will get a grid pattern of those parts. Okay. And again, it's using the separation between the parts from the curve setting that I have set within the task parameters for the Common Cut curve settings. You can ignore or not worry about the actual lead-in that's there, because the AutoNC sequencing takes care of the actual lead-in for you, and we'll actually bypass that and ignore the initial lead-in like that, so it doesn't cut into the other parts. The other option is the multi part, and what I'm going to do is I'm going to pull up a task that actually has some parts in it, and we'll do a multiple part task. So what I want to do here now is follow through to the next step of applying the NC so you can see the differences. So I'm going to switch this back to single part, re-nest it with a single part. So now I'll have the parts separated by one common edge. And then the next step would be to follow it up with the AutoNC. So I go to Nesting NC, open up my AutoNC functions. I'll go to the Common Cutting tab, turn it on, and then this is where I get to pick the type. So either cut rapid cut, 1 pierce 2 parts, 1 pierce 2 parts laser, and auto slit. You can use all of these functions here or types for this type of nest. Most commonly would be the 1 pierce 2 parts laser. Then, because I already had my curve set up at the task level, I can just say use the task parameters, or you can say, oh, I want to change it to whatever setting it is. But when you do that, just make sure that your part spacing equals that user-defined setting that you've set, so that they match. Okay. I don't have to worry about a previous pickup point in this case, because that's mainly used more for the common cutting type of cut rapid cut. The next thing that we can look at is applying lead-ins and lead-outs if I want to. So if I want to add in lead-in and lead-outs, I'll use half the distance from my lead-out and 1/8 inch lead-in. I'll go now ahead and apply the NC. And then when we take a look at the sequence, it'll cut the internal hole for the first part, then the second part, splits the center around the outside, and finishes off. This is where we're talking about the pickup points for this location right here, because the first part would actually be finished at that point, and then this is where a pickup point can be introduced in so that it extends the cut into that next part, so that if it does tip, that your head would be away from it from the previous pickup point. I'm going to clear the NC, and I'll change the auto NC type for the common cutting to, let's say, the cut rapid cut. And then this is where I can introduce in the prep cuts, say 1 inch. And then when it goes ahead and it applies it, there it goes to it's cut the one part, goes to the actual common edge and around. It's actually the same sequencing. If I change the nesting type, by the way, on a part like this, you can still also use the auto slit too. So if I apply the auto slit, it's going to split the center and then around the outside. But when you do this, be aware of all the holes will be cut in the whole grid of that part first, and then splits the center, then starts off around the outside. Okay. I'll go ahead and remove the NC. I'll readjust the parameters, the task parameters for same part, and I still have my kerf setting set to kerf lookup. I'll reapply the nest settings. So now I have a same part layout where all the common edges are then looked at, and in this case I get a grid pattern of those parts. When applying the auto NC for the common cutting, I have basically then two options that I can use: the cut rapid cut and the auto slit. If I use the cut rapid cut, this is definitely where you want to use the double prep points, double prep cuts. I'll put in a 1 inch there. I got my lead in. I'll put in a lead out. Let's say 80 thousandths. And then when we go through this sequence, I'll show you the way that it's splitting up the actual cuts here. Let me take a look at my settings. Hold on. There we go. Cut rapid cut, double prep cut, 1 inch, lead in, lead out. Okay. And it's not putting in the prep cuts. Let me try the other nesting type. Cut rapid cut, double prep cuts, 1 inch. down. I'll hit set to default so I don't have to keep resetting that. And it's not putting in the prep cuts. I will have to take a look at why that is happening. Right now, I'm not sure. Distance 16ths, which is right. Yeah, right now it's not putting in the prep cuts for me. I have to find out why that's happening. But in this one, what it does is it'll cut the first part, goes around. Now the first part is cut. Then it starts up on the second part. And when it goes to cut the other sides, it'll cut the other 3 sides of that one part and then continues on in that fashion. So it's basically cutting one part at a time. This method is used for accuracy for the common cutting versus the auto slit. You can have more movement in the common cutting, releasing the stress within the material, and you can get the internal parts moving more than you want them to. So in this case here, you're maintaining the sheet stability as it's cutting along. Okay. The other option that you have that you can apply within the auto NC for this type of nesting is going to be the auto slit. And in this case here, when we go ahead and apply it, it's going to do all of the internal holes first. And then after all the internal holes are done, then it's going to do all of the internal cuts for the edges, for the common lines. So now it's going to do the slicing and then the dicing of the internals, and then goes around the outside. So that is the auto slit. And then what I'm going to do now is show the function for the multiple. So let me open up a task here that for the multiple parts. I'm going to edit the parts here real quickly to have the common cutting function turned on. So I'm doing the global editing. Select all the parts. Now I have the common cutting turned on. I already have a task that the parts are in it. So I'm just going to open up one of the parts in part mode, update the parts, go to the task that's already there, change my setting from the common cutting where it's turned off to multiple part. And again, I'm just going to use the curve lookup and auto nest it. Now I have those parts that are common cut in a multiple part option. All the parts got moved up to the top. That's just because within the task parameters, the reference point was set to opposite reference if I went to same as reference point, and I redid it. They'll all be bumped down to the lower left corner. Okay, so now it's same reference, same as reference point, and then I'll re-nest it, and now they'll be nested to the bottom left. And here you can see where the parts are nested together. So you have smaller parts and bigger parts that are common cut together. And then in this function here, when I apply the auto NC to it, I would most likely use the cut rapid cut feature, so it cuts out one part at a time. And then when I go through my sequencing of this, here you can see a prep cut right here. If I back it up, cuts to, it's starting from the edge, goes to the common cut area, but it goes, instead of going through the common cut, it goes through the next part, throws in the prep cut into the other part, and we'll do that on the other side also, where it extends the prep cut into the other part, finishes off that part, and then when it cuts the next part next to it, and right there is when it cuts the next part, the pickup point is now starting at that prep cut, and which is about approximately the 1 inch away. And now that's the safety feature. So now the head's out of the way in case that part does get loose, and just continues on that process for the entire nest. And anytime that you do have a common edge, it will put in those prep cuts for you. Okay. Now we do have a radius that's also here in this part here. And if this is the case here, if you wanted to use the transition option to actually put in a transition point, you can. Usually it's when you have two radiuses that are on both sides of the common cut. In this case here, there's only one radius side, so this would be okay. If there's any other questions that you guys have at this time or would like me to show you, you can go ahead and ask me at that time, or right now would be fine. Okay.
One second here, I'm looking at the questions.
Yeah, go ahead.
So Michael says that he is using a Whitney 370 SST combo plasma punch machine. The cutting head is stationary and the table moves the material and parts drop through the trapdoor. Would
Yes.
cut rapid cut be the best option to prevent your material getting bound up as the table moves?
For Whitney's, for plate processing machines like that, probably the best option is to use the multiple drop function. So in this case here, within the nesting type, for that particular type of machine, there is a option here for multi-drop. What that does is, instead of using the common cutting as the standard sequencing, what this does is it will group some parts in a vertical line across the sheet, and then it will then try to sequence it so that as it's cutting the last edge, it cuts the last edge of all the parts at one time, so then the trap door can all open at the same time for those parts so that it doesn't cut out one part at a time. Typically for combo machines, the common cut is not supported, so it's extremely hard to do it on a combo machine like that. So we have this multiple drop function here where it will still do common cutting, but for the group of parts to release all the parts within one group so that they can fall at, so the drop door can open up and all the parts within that group fall down at one time, if that answers the question.
All right. We have another question from Jeffrey, and I'm not sure if we're going to need a specific example or not, so I'm just going to ask you and let you determine that. Can you show manual alignment for those of us who don't have Techno?
Yeah. So I'm just going to use a single part here. I'll make a new task. I'll pull that part over. Oh, not all of them, just that one. There we go. And then I'm going to keep the common cutting automatic features turned off. So in this case here, if I wanted to do it manually, your other options here is to, one, you can use the common cutting nesting icon here, and then when I do that, I can nest the parts based off of the options that I have, or the settings that I have available. Now, nested all two of them because I didn't check my settings in here, so let's get some more parts in there. There we go. And then I can just use, oh, let's start from the beginning here. Check to see what the part spacing is. Okay. Use test parameters, curve lookup. There we go. Now I'm using the curve lookup values from the tech table. And if you look at the actual spacing now and we measure it, it should equal the spacing that we told it to from our curve lookup while we were doing it. So that's all within the command line option. Okay, so when you do select it and then select the part within the dialog box, I already nested all 10. Let me get rid of one so it can activate. There it is. And then on the very bottom here is where I told it to use the curve lookup, which is actually 16 thousandths, or you can actually set the user define and then set it to anything other than what the tech table currently has. The other method of doing that really quickly then would be using the array functions. So if I have, let's say, one part, I can use either the dynamic array, and in your part parameters, before I do this, I can preset my part clearance distance, let's say to 16 thousandths. Select the dynamic array, select the part, and then go up with it to how far I want to go up. And Then I can take that and go over and use the dynamic array to array those parts at that spacing that I told it to. So again, this spacing here is at 16 thousandths for the horizontal and the verticals. The other way of doing it, besides the dynamic array, and let's get rid of these parts and start with the one part again, is to use just the regular array function. Select the part that you want to array, and then you have your controls on the left to how you want to array them. So I'll say I want to go in that direction. I'll just use the offset distance and put the offset distance of, let's say, 16 thousandths in here, and say I want to go 3 up, or yeah, we'll go 3 up. And then, or that's 3 over, and then same for the vertical. I can set to the distance there and say I want to go 3 up from there, and then hit the OK, apply button, exit out of there. So now I have a grid pattern of these parts here spaced out at the distance of 16 thousandths. So that would be your manual nesting of come and cut parts. Then the next step is when you apply the NC of it, you have to have the advanced NC profiling so that you get the common cut option. So now in here, I can go ahead and apply, if I will, the cut rapid cut or the auto slit function for this type of nest. In this case, I selected the auto slit. Oh, let's make sure that my kerf setting was set right. And we're going to say user define, and I had it at 16 thousandths, so that was my user define, and because it did not, the tech table did not match it, it did not apply the auto NC, so I forgot to change it to the user define, and now I'm setting the kerf. Now it matches what's there. As long as your part spacing is the same distance as that kerf setting, it will now apply then the come and cutting sequencing, which it just did. So now it's going to do the parts. And this is the cut rapid cut feature. Cuts one part basically at a time, and then the adjacent edges. Okay. And then there's also the cut rapid or the auto slit function that can be used. I got to use the user define, specify what that is so that it applies it. And now here is the auto slit function. This would be the fastest way of doing it, but as you can see here, it's going to do all of the internal holes first. Then it does what I call the slicing of the internal common edges, and then the dicing of the common edges. Once it's done with that, it goes to the outside of the part or the grid, and then cuts around the outside of the grid. Any other questions?
All right, so far no other questions have been asked. So at this point, I'm going to give everybody about 30 seconds to put in any additional questions if they have any.
Yeah, that's fine.
But while we're waiting, I'd like to go ahead and talk about our knowledge base and our future webinars. So we have something called the knowledge base, and Lloyd, can you bring that up for me?
Yeah.
So our knowledge base is a form that is kind of new to us and is still in the process of being built to its fullest potential. We add tons of articles and videos and tutorials, as well as our past webinars to the knowledge base pretty much weekly. So if you've missed any webinars, or if you don't have a chance to see future webinars, you can always go to our knowledge base and get those, as well as articles. Typically when we have a webinar, we will also create an article to go along with that webinar, so that you don't necessarily have to spend time later watching the entire webinar if you're just looking for one detail. So we have articles based on all of our webinars, as well as other topics. And then we also have tutorials and a bunch of great content on there as well. So next week, or not next week, the week after next, Friday the 19th of October, we will be having another webinar. Currently we're doing every 2 weeks rather than once weekly as we have done in the past. But we will be having advanced report editing webinar. We did a basic report editing webinar recently, so if you haven't seen that one, you can find it on our knowledge base, and you'll be able to see the basic editing to follow along with the advanced report editing if you'd like to sign up for that on the 19th, and if you have not seen that previous webinar as well. So at this time, I don't see any other questions. Lloyd, I'd like to thank you for preparing such a nice webinar for us, and I'd like to thank everybody for giving us their time on this Friday. We hope you have a good weekend, and we hope to see you at Advanced Report Editing on the 19th.
Thank you, everybody, for coming.